Welcome to Academic Digest class. Today we'll be treating redox reaction. We said that redox reaction is coined from the word reduction and oxidation. It's coined from the word reduction and oxidation. So reduction is the process or is a type of reaction whereby electrons are lost or electrons are gained or electrons are accepted into an atom. So it involves electron gain of electron. So it's a type of reaction that involves electron gain. Why oxidation reaction is a type of reaction that involves electron loss. So we also say that oxidation reaction is a type of reaction that involves oxygen gain, a gain in oxygen. Why this one is a type of reaction that involves oxygen loss. Also, oxidation reaction is a type of reaction that involves hydrogen loss. While reduction reaction is a type of reaction that involves hydrogen gain. Oxidation reaction is a type of reaction that involves an increase in oxidation number. While reduction reaction is a type of reaction that involves a decrease in oxidation number. Okay. Now, we need to understand that in doing oxidation reaction or redox reaction, that there are concepts that we need to know. And one of those concepts is that what we call valency is very important. We know that there's something called polarity, first of all. So the same principle applies. Is either an element. Every element has the chance of gaining electrons to become more electronegative, or losing electron to become electropositive or to have more positivity. So for example, an oxygen element, this is oxygen, not oxygen gas, oxygen, is number 8 in the periodic table. It will have 2 6. So it has 6 valency. Now this valence is the combining power, what is required. So if you have 6, it's easy for you to gain 2 than to lose 6. So but if you check it, oxygen has this valency, that is +2 and -2. So it now depends on the condition. Another element is sulfur. Sulfur is number 16. It will have 2, 8 and 6. The valency of sulfur is such that it loses 6 to become positive, leave charged to become a metal, or it gains 2 electrons, and it's easy to gain 2 than to lose 6. So that is why we normally use -2, but it depends. So we say that valency is the combining power of an element. So if I know this, a question can come, they tell you find the oxidation number of sulfur in Na2SO4. Now to do this, to get this oxidation number, to find the oxidation number of sulfur in this, you call sulfur X. Now notice sodium is number 11 in the periodic table, which means it will have 2 8. 2 plus 8 is 10, then 1. So see, it's easy for sodium only has one option: lose 1 and become positively, or gain 7 and become -7. And it's easy to lose 1 than to gain 7. So we'll put -1 for sodium. That is the valency. Then have 2 here plus. So the sum total of atomic valencies is what you use to check oxidation number. So plus oxygen, now using the same principle, the valency of oxygen is between +6 and -2, but let's use -2. That's the most part. So 6. And you need to know the rules of oxidation. The rules of oxidation, the first rule of redox reaction is that every element, let's say magnesium, aluminium, every element or compound without an ion, every element or compound has an oxidation number which is equals to 0. And every ionic element or compound is equals to the charge. The oxidation number is equals to the charge. You need to note this. These are principles you must note. So if I know this, that means that this particular element, because this particular compound, because everything is not having charge, is equals to 0. So by the time I do this, I have minus 2 plus x minus 4 times 2 is minus 8 equals to 0. Now notice that minus 2 this sodium is plus 1 from here, so it's plus 1, so plus 2. So minus, this will be plus 2 minus 8 plus x equals to 0. So this is minus 6 plus x equals to 0. And when x cross equality sign, it becomes 6. It becomes 6. So sulfur here is having an oxidation number of 6. So that is the same way, the same principle. I can give you examples for you to solve for me. Let me find the question. So remember I said this is what we call rules of oxidation or rules of redox reaction. Major rules. So there are so many of them. So an example is, let's say that we are asked to find what is the oxidation number of, let's say, sulfur in this. Then let's say this is number 3. Then I ask us what is the oxidation number of chromium, that is Cr, in this compound here, that is Cr2O7 2-. Now let's say they ask us here, what is the oxidation number of oxygen? In H2SO4. So that's your classwork. Or I will solve the number 3. So you take number 2 and number 4 as your classwork. So in order to do this, I will say Cr2O7 2-. Since it's an ionic compound, this is going to be decided as say Cr2O7 is equals to minus 2, because the charge here is minus 2. So applying that rule, that every ionic compound, the oxidation number is equals to the charge. So if I do this, so since it's Cr chromium I'm finding, I call it X times 2. Now I already know plus, I already know that oxygen is number 8, 2, 6. It will either gain 2 or lose 6. So it's easy to gain 2 than lose 6. So I put minus 2. Then I have 7 equals to minus 2. 7 times this becomes minus 14 plus 2 times x, 2x equals to minus 2. So this is now going to be 2x equals to, yes, Shemi? Yes. So this is now going to be the same thing as saying, if this cross equality sign, it becomes plus, minus 2 plus 14. So this is going to be 12, 2x. So divide both sides by coefficient of x. So x is equals to 2. It's equals to 6, sorry. Which means, therefore, chromium, Cr, is equals to 6. The oxidation number is equals to 6. That's the answer. So from here, we'll move to the next part, which is balancing redox reaction in acidic medium. So we have all these questions. We have these questions. See question 1, question 2, question 3, question 4, question 5, question 6, question 7, question 8. So I will solve question 1 and question 2. You use the rest as your assignment. So before I do this, let me give you the rule. So the first rule, rule 1, is to check for increase in oxidation number. Check for increase in oxidation number. That's the first rule. You will see us doing it so that you understand better. The second rule is to separate the reaction into oxidation half reaction. Number 3 is to separate the reaction into reduction half reaction. So you can consider this to be the same rule. So it's the same thing as saying separate the reaction into oxidation and reduction half cell reaction. So this is like 2A and 2B. 2A and 2B. So number 3 now. When you're done separating, add water, H2O, to the parts with less or no oxygen. Number 4, add hydrogen ion. Remember, it's acidic medium we are doing. Add hydrogen ion or hydrozonium ion, but let's use hydrogen ion, to the parts with less or no hydrogen. Number 5, when you are done doing this, balance the charges on each half cell reaction by adding electrons. Number 6, balance the electron now on both half cell reaction to be equal by multiplying with the coefficients of electron interchangeably. You see us solving this so you understand it better. Interchangeably. Number 7, combine left and right hand side of both reactions and then cancel out the electrons, and boom, you have your reaction to be balanced. So these are the 7 rules of balanced redox reaction in acidic medium. So let's try to look at it now and see for ourselves. So I'll be using the rule. Let me write out the first one. So let's solve this question. So what I will do here is to check for increase in oxidation number. Notice that this one has minus. This compound has minus here. But here its manganese is +2. So here the whole compound is an ionic compound, so it's equals to -1. Even the manganese there is equals to -1. But here manganese is equals to +2. Why here every compound standing is on its own, or element standing on its own, this is an element iodine, is equals to 0. Here is having 2 times minus times 2. Here is having -2. So there's an increase in oxidation number here. So I will say I've checked for the oxidation number, which is rule 1. So I will say, let me apply rule 2. So I'm separating it now. So oxidation half cell reaction, that is reaction, that is rule 2. This is rule 1, finding out the increase. Rule 2. So oxidation half cell reaction will be MnO4 minus 2 Mn2 plus. That's increase. Then for the oxidation half cell reaction number 3, that is 2b, sorry. So reduction, for reduction, sorry, reduction half cell reaction will now be iodine to 2I minus. So notice the rule said that we should add oxygen. That is the next one. Add water, sorry, to the part with less or no oxygen. So notice that here, this is having 4 oxygen. Here, no oxygen. So I'll add 4H2O plus 4H2O. Why am I adding 4H2O? So that I have 4 times O, now 4. So I have water, I have oxygen 4 now. But notice that here, I'm now having 2 times 4, 8 hydrogen. But I don't have it here. Now there's a rule that said add H plus to the part with less or no hydrogen. So I'll now do plus, I'll add H plus. Why? Because this is 2 times 4. So I'll add H plus. Now notice another thing. The next rule says balance the charges on each half cell reaction. So let me balance the charges on oxidation and reduction half cell reaction. That is number 5. So to balance the charges, I will count plus, that is plus, this plus times 8 will be plus 8. Then there's minus 1 here. So 8 minus 1 is 7. Here I'm having 2 times, there's invisible 1 here. So plus 2. I have 2 charges on the right, 7 charges on the left. So the only way to balance this is to add 5 electrons, because electron is negative. So if I add 5 E minus here, it will now be 7 minus 5, which is equals to plus 2. So I'm now having plus 2 here, plus 2 here. I added that 5. Somebody wants to ask me, why did you add 5? I added 5 because I noticed that it was initially 7 one side, 2 other side. And the rule of conservation, or rule of gravimetric laws, states that whatever you have on the left hand side must be equal to what you have on the right hand side. So reactions, reactants and products are equal in energy, mass, matter, neither created nor destroyed. So if I know that, I will now move to this part to balance. Notice that right here, I have 1 minus times 2 minus 2. Here any element on this one is 0. So I have minus 2 charge here, I have 0 here. So add plus 2E minus here. So this is now minus 2 balanced. So the charges on both sides are equal. Now the next thing is to apply the C rule, which says balance the electrons on both half cell reaction to be equal by multiplying the coefficient of with the coefficients of electrons interchangeably. See what that thing means. Notice that here I have 5 electrons in the first one. Here I have 2 electrons here. So I will simply carry these 2 here, use it to multiply this. Then here I have 5, use this 5 to multiply this side. Reason is that by the time 5 times 2 it becomes 10, by the time 2 times 5 it becomes 10, and I want these electrons, the electrons on both sides, to be equal. So that's why. So that's rule 6. Rule 6, I'm doing it here. So I'm now going to be having 2 Mn. So rule 6 is what I applied. I'm not writing it up. So I now have 2 MnO4 minus plus 16H plus 10E minus 2 2Mn2 plus 8H2O. Now if I do this one now, I'll have 5I2, that is 5 iodine plus 10 electrons, then 2 iodine, sorry, 5 times 2, 10 iodine, ion. Now notice something, there is, okay, Wow. Okay. I think the problem started. I think notice I'm having an electron this way and an electron this way as well. Wow. So I can say cancel out. I just wonder, the electron is supposed to be this way. So, but I can say at this point, cancel out the electrons on this, just as the rule gave. So that I now have, so that I now have 2mn, then combining everything here with what is here. So I now have 2MnO4 minus plus 16H plus 5 iodine. The problem I have is that this equation that was given, iodine is supposed to be here and the iron is supposed to be here. So the equation was given that way. So I2 2Mn2 plus 8H2O plus 10I minus. Okay. So if I check this now, I'm having minus times 2 minus 2, then plus 16, so which is 14. Let's do this one. I'm having minus 10, then this is 4, and this is going to, this is not correct, this is wrong. Why is it wrong? The equation is supposed to be this way. The equation from the first place, the equation is supposed to be in this format. This is supposed to be 2i. I got this question from online. 2i, then this is supposed to be I2. So that by the time you do it, you see that this is supposed to have the 2i this way minus, and then, okay, let's do it here. Let's do it in